Welcome to our video module on number 4 on the homework assignment. And I'd like to take a quick moment to go over this both for the for the undergraduate and the graduate students. And first, we need to note that there's two questions going on here. First is the experimental compound is on the bearing, and there's 12 bearings on each tank. So we have to figure out the probability that one tank, what's the probability of success for one tank? And then from there, we can find out the probability, the question, what's the probability that at least one vehicle completes the test? And what's the probability that at least 3 vehicles complete the test? So let's start off with using the bearing information to identify the success rate for the tanks. And here we're going to use n choose x. So n choose x, probability of success to the x power. And then we're going to choose the probability of failure, which is 1 minus the probability of success, to the n minus x power. And we're going to do this for each way that we choose. So for each option. So for as long as at least 10 bearings remain functional. So that's 10 bearings, 11 bearings, and all 12 bearings. Well, all 12 bearings is going to be 12, and we're going to choose 12 successes times probability of success raised to the 12th, and then times, and I'm going to substitute out here probability of failure, PF, just to make it a little bit faster. Probability of failure raised to the 0 power. We're going to add that now to 11. 12, choose 11, and probability of success to the 11th power, probability of failure to the 1st, and then finally we're going to do 12, choose 10, probability of success to the 10th power, probability of failure. And I'm going to plug in the numbers for the first one. 12, choose 12 is just 1. Probability of success is 0.98. Actually, I'll do the first two. 0.98 to the 12th. Probability of failure is 0.02, but it's to the 0th power, so that's just going to be 1. And then the next one will be 12, choose 11. That's 12. I'll let you do that math. 0.98 raised to the 11th power times 0.02 to the 1st. And let's put in the final one while I'm at it. 12, choose 10, I believe is 60. Please check my math on that. Yeah, that looks right.
And just a quick note on this, that should be 66. I realized that during editing, so just keep that in mind when you're looking at the solutions. But the final number, I didn't chase down to adequate accuracy to be able to reflect this mistake.
0.98 to the 10th and 0.02 squared, and the equals on that is going to be the largest one will be here, and the solution is 0.785. So what's that tell us? That tells us that there's a 78.5% chance that all bearings are going to succeed. And then you're going to add to that 0.192. That's this term right here. That's the probability that only one fails. And finally, 0.0216. That is the probability that 2 fail. And you can see how they're getting smaller. You add all those together, and you get 0.9986. That is the probability that one tank, right here, probability of one tank succeeding is 0.9986, which is actually a lot higher than the 98%, and that's because only 10 or more bearings need to remain functional. Great. Well, let's get used to let's get rid of that, and let's that is for undergrad and grad. Now, what's the probability that at least one vehicle completes the test? There's 16 tanks here. At least one. Well, the probability of at least one completing, probability of success for greater than 1 tank is equal to 1 minus the probability of all of them failing. Probability of failure for all. And so that all we do here is we do 1 minus, and the probability of 1 failing is is 1 minus 0.9986, and we're going to raise that to the 16th power because that's how many tanks have to fail. So when we run those numbers, we get 1 minus 2.2 times 10 to the negative 46, actually 2.18. And my apologies to Gage here. Yeah, you were saying that this is really close to 1, all right? But if you had said, and this is what I was trying to get at, I just wasn't clear on it. If you had just said, oh, this is close to 1 and not done this calculation, that wouldn't have been okay. Because what we can do is we can actually use this. Like, we can actually see this 1 minus a really, really small number. Now, if I had asked you to square this or raise it to a power, at that point, you could say, you know, that number squared, you could say that equals 1 because, quite frankly, your calculator can't even do it. So for the grad students, we're looking at least 3 vehicles succeed. Probably that at least 3 vehicles succeed. So success for at least 3. Now what we could do is we could say the probability that 3 plus the probability that 4 plus the probability 5 plus the probability 6, okay? That takes forever because you have to go 3 to 16. What we're looking for then is 1 minus the probability, what's the other option? 0, 1, or 2 of them completed. So that could be 1 minus the probability that 0 tanks. 1 minus, and it's going to be the addition, probability of 0 tanks plus probability of 1 tank. How are we going to do this? Success 0 tank, success 1 tank plus probability of success 2 tanks. Okay. So we know this one is this is the undergraduate question. What is the probability that no tanks make it? They all fail. That's going to end up being this 2.2 times 10 to the negative 6. All right, so it's going to be 1 minus 2.2 times 10 to the negative 46 plus the probability that 1 tank succeeds. Now this is where it's going to get a little messy for you all.
And my apologies again. Bear with me on this as I go through this. I later realized that I'm doing 16, not 12.
Because you're going to have 12, choose 1, and you're going to have 0.9986 raised to the first power and 0.0014 raised to the 11th power. And then you're going to have to do probability of 12, 2, same basic idea. Here we're going to have to continue that down here. 0.9986 to the second power times 0.0014 to the 10th power. And this is where I was saying that for the grad students, this is like cold and heartless, because while with the undergraduates, you can just put this down. You can subtract effectively. With the grad students, there's no way to add all these together because they're such small terms. Oh, and one mistake I see here is that this is 16, choose 1. So this is 1, this is 16, and this is 16, choose 2. So this is 2, and then a 14. Sorry, and that would mean that this one is 15. My apologies. And so when we look at the solution here, we will see that this term is most important in all of this because it's the largest by several orders of magnitude. So we get something like 1.33 times 10 to the negative 38. But that's just approximate. So what I've done is I've gone over to Excel. Let's bring that over. And what I've done here is I've actually done this. So you can see, if I were to say, well, what is the number? Well, you can use MATLAB or you can use Excel. I've done Excel because it's accessible to everybody. And we can just choose all these, choose the number. And what I've basically done is, as you can see here, I've put in the solution to the first term, and then here I've put in the solution to the second term, where I've just done 12 times 0.9986 times 0.014 to the 15th. And then here, oh, whoops, it should be 16. And so this is correct. Let's review that. 16 times 0.9986, 0.014 to the 15th. And then finally 120, which should be 15 times 8, 0.9986 squared, 0.014 to the 14th. And notice they're all zeros. Well, let's just, we've changed the format to numbers, and then we just start increasing until things start showing up. And as you can see, like, this is just silly as far as the type of decimals we're dealing with here. And this is kind of why I felt mildly guilty about giving something like this to you. So this right here is the solution. And let's do one more so we can see all those decimals. Oh, whoops. There you go. And there are all those decimals. So really what we have right here is it's about equal to this, which, yes, just to be clear, is about equal to 1. So my apologies in class for simply brushing this off as not close to 1. Yes, it's close to 1, but it's something that we can calculate and demonstrate. For the grad, I was kind of preoccupied by this on the grad student side, that really is so close to 1 that your calculator can't even find it. Hopefully this gives you some insight for this problem. And I don't expect I would do a problem this cruel for you on an exam, simply because of the calculations. But if I were to change this number from 98% down to, say, 90% or 85%, then I think it'd be really fair. Thanks, we'll see you soon.